Okay, we're doing lesson 2.6. Today's October 11th, 2011. We're going to go over maximizing surface area and maximizing volume. So, our first question says Rosa constructs a rectangular prism using exactly 384 square inches of cardboard. So, in other words, Rosa has 384 inches squared of cardboard. So, are they working with volume or are they working with area to start with? Area. Because it's squared, we know we're working with area. And it says they constructed a box. So it is a three-dimensional shape. So we're going to quickly draw a diagram of that. So we have our rectangular prism, which we've just drawn a diagram of. And we know that its surface area, our surface area of it, is going to be 384 square inches. We need to maximize the volume. Now, the other day we learned something about four-sided shapes. What four-sided shape will maximize area? Close, square. Cube is three-dimensional. That's the right idea. It's going to be a square. So for our prism, we actually need to be creating a square. A cube. So even though we have a rectangular prism here, we're going to replace that. Okay, so we have our cube, and I need a formula for the surface area of a cube. I know that every side of this cube is actually going to have the same area, no matter which one we point to. They're all squares. A cube, every side is the exact same area. So the surface area of this cube is going to be equal to one side multiplied by another side times the total number of sides. So we have 6 sides, and we know we have to multiply one side by the other side, okay? And we could simplify s times s. We could turn this into the surface area of a cube is 6 times s squared. All the sides are also the same length because we're working with a cube. So what we're trying to figure out now is, because we eventually want to maximize the volume of this shape, I actually have to figure out how long one of the sides are. Now I do have the surface area from above. We knew that we were working with 384 square inches. So I'm actually going to plug that in for the surface area. So we have 384 is equal to the surface area of a cube. So 6 times s squared. Now we need to isolate for s. So the first thing I'm going to do is I'm going to be bringing the 6 to the other side. Because this is 6 times s, when it goes to the other side, we have to divide. So we're going to divide both sides by 6. We'll end up with s squared is equal to 64. Okay. And in order to get the s again by itself, we're going to need to square root both sides, because that is s squared. So we'll square root both sides. On the right side, we'll have just s left over. And the square root of 64? 8. Good. So we know that the sides of this box she's constructed need to be each 8 inches long and 8 inches high. I'm just going to get rid of the s's now. And finally, 8 inches deep. So the dimensions of this box need to be 8 by 8 by 8 in order to maximize our volume. We can solve what our volume is going to be by doing this also, okay? So if we need to know what the actual volume is, the volume of a cube is going to be one side times the other side times the other side, or as we know them as our length times height times depth. Because all the sides are the same in a cube, volume is equal to side times side times side. That can be simplified. Remember our exponent rules? S times s times s is the same as writing s cubed. Okay? We know that one side is 8 inches, so we substitute 8 in for the s. It's not to the power of s. 8 to the power of 3. And when we type in 8 to the power of 3 in a calculator, 512. So the volume of the cardboard box we just made is 512 inches cubed because we're working with 3 dimensions. Okay, in our second example, we have Liam constructs a rectangular prism with a volume of exactly 1,331 meters cubed. So they've given us the volume this time. Liam built a rectangular prism, and the volume of the object was 131 meters cubed. That's huge. Okay, so we have the volume of this cube. It has the least surface area possible. What are the dimensions? So again, we're trying to find now the least surface area possible. In order to do that, we're using the same shape we used in the question before. So we're going to just quickly copy it here. Okay, so our object again is going to be a cube. We need to find the least surface area possible. Well, to start off, we know what our volume is, and we discovered in the last question that the volume of a cube was s cubed, or in other words, one side times a side times a side. We need to actually figure out what each of these side lengths is in this specific shape. Okay, so we know the volume is equal to 1,331 meters cubed. So we're going to substitute that in for the volume of this shape. Again, we have to find out what S is. So in order to find out what S is, we need to find the cubed root. What that looks like on your calculator, we'll write it in again here. The cubed root on your calculator is going to have a square root looking sign with a 3 above the little edge. So we're going to find the cubed root of both sides. When we find the cubed root of s cubed, these two will cancel out and we're left with just s. And we have to find the cubed root of 1,331. I do it on this calculator. I need a better calculator for this. Anyways, it ends up being 11 when you type it into your calculator. If you're not sure how to do it, one way you can reverse doing it. Hopefully this doesn't confuse you. 1,331. You can put things to the power. If you can't find a cubed root on something, put this number, and we'll do it in red on the side. 131, 331. To the power of, usually it looks like a hi-hat on your calculator. To a third, okay? If you put that in the calculator, that's the same as finding the cubed root. So, to the power of 1 divided by 3, end brackets, equals 11, okay? So you can do that way if you can't find cubed root on your calculator. So now we discover that one side is equal to 11 meters. One side is 11 meters. We need to find out the minimum surface area possible. From the question before, again, that was 11. Our surface area we knew was going to be equal to the 6 sides, and the area of each side was a side times a side, which is s squared. So that's the surface area of this cube. We knew our sides were 11, so we're going to plug that in. 6 times 121. 11 squared is 121. And 6 times that will be 726 meters squared. So what we just figured out was that with a volume of 1,331 meters cubed, the minimum surface area would be 726 meters squared. So we minimize surface area in this example In the example before, we maximized the volume. Okay, example 2.
Where'd that go? I saw that.
Yale is designing a glass candle holder. It will be a rectangular prism with an outer surface area of 225 and a square base with no top. So, we know the base of this object is going to be a square. So we know that both sides will be the same measurement. We don't know the height of this object. We'll call that h. And we do know that the top of this is missing. So consider that there's a hole in it. That's why they're making a candle holder. You got to be able to put something in it. So they said the surface area of this object was equal to 225 centimeters squared. Now, I actually have to figure out a formula for the surface area because it's not the same as before. Normally, surface area for a shape like this, now remember we have a square on the bottom, so I know the area of the bottom is going to be S times S, and normally there's a top and a bottom. So normally we would have 2 times S, which is S squared. So, our surface area of both the top and the bottom comes out to this, but we would also have to add the surface area of the 4 rectangular objects on the sides. Okay? Now, the area of one of those would be a side times the height. That would give us the entire area of one of these, and we know there are 4 of them. So we would have 4 times S times H. Now, that is the surface area for a normal object like this. The only thing that's different is we said that this would be missing a top. So we no longer need 2 square objects or 2 square areas. We can get rid of the 2, and we're going to work with a surface area that's equal to S squared plus 4 times S times H. So that's the surface area we're going to be working with. We need to find a surface area that will maximize the volume, okay? So we actually have to play around with the formula we've just created. We need to figure out what the height of this object is going to be. We know that the 2 sides are going to have to be the same side length because it's going to be a square, but we need to figure out what our h is going to be. So we're going to be doing trial and error like we've done before. So we're going to actually make a chart. But what we're going to do first is we're actually going to rearrange this formula. SA is equal to S squared plus 4SH. I want to isolate this so that I'm solving for h at all times. So I'm going to move the S squared to the other side of the equation. I end up with surface area minus S squared is equal to 4SH. And since each of these is multiplied by each other, and I'm trying to isolate just the h, I'm going to divide both sides of the equation by 4s. When I divide the right side of the equation by 4s, the 4s on top and bottom will cancel out, and we'll be left with just h. And on this side, we'll be left with the surface area subtracted by s squared divided by 4s is equal to h. Now, there is one piece of information I can add to this. They have told me that the surface area is 225. So, I'm going to replace my SA, which stands for surface area, with 225. So the formula we're working with is 225. Subtract s squared divided by 4s equals h. Now from here, I have to do trial and error. I have to make a chart like before and plug in different values of s to find out which one's going to maximize our volume. So we're going to build a chart. Sorry, one last thing we do need to know is how to find the volume of this shape. And because it's rectangular, we're just going to multiply the side by the height. Okay? So the volume of this shape would be S times H, which is also the same as S squared times H. Okay? So we're going to build a chart now. Your chart's going to need to be... Okay, so we've put the chart up. We know that the surface area for every different shape we try is going to be 225. So I've put these little quotations. That means every surface area is going to be 225. That number is not going to change. Okay, so the easiest measurement we're going to start with is if the base or one of the sides is the number 1. Okay? So what that means is I need to take that number 1 and I need to plug it into this formula down here. I need to plug 1 in for both of the S's to solve for what the height would be. And then once I have the height, I can solve for what the volume of the shape would be. So first example, call this a very first example, 225 subtract 1 squared over 4 times 1. It's going to give me the height. So I get 225 subtract 1 divided by 4. 224 divided by 4. Our H is 56. So, now that I know the height is 56, I put it into a volume formula. Volume is S squared, which we tried as the number 1, and the height is 56. So, our volume becomes 1 squared times 56. 1 times 1 is 1, times 56 is 56. So the volume of this shape is 56. Once I found out one of them, I have to try the next number along the base. So if the base was 2, I plug it into that formula. We'll call this a second example. So number 2, 225 minus 2 squared divided by 4 times 2 equals H. I get 225 minus 4 divided by 8 is H. 221 divided by 8 equals H. Our H ends up being 27.6. Okay? So the height in this case would be 27.6. We have a different height in our prism now if the base is wider, which makes sense because we have a limited amount of material to work with. Now I have to find the volume of that shape. The volume will be our 2 sides squared times 27.6 becomes 4 times 27.6, which becomes 110.5. So our volume is now 110.5. Now, I'm going to fill in the rest of this chart just so it makes sense. Those are the steps you'd have to go through. The next one you'd have to try base 3, then base 4, 5, 6, 7, all the way down until you found a volume, until you found what would be the greatest volume, okay? Actually, what I'll do is I'm going to jump down this chart and I'm going to tell you that the greatest volume is at 9 by 9 by 4. Okay? So if the base, I'll quickly show you what that means. That same surface area question, 225, minus if our side length was 9 squared divided by 4 times 9 is equal to the height. 225 subtract 81 divided by 36 gives us our height. I think our height ends up being 4. And then our volume ends up being 9 squared. That's the side length squared times 4. We end up with 81 by 4. 324. So after doing all of those examples, 324 ends up being our max volume. So what we discovered about this is that our max volume from the ones we've tried when we went through this was 324 when our base length was 9 and our height was 6. Now, if you guys look, all right, gentlemen, homework, page 110, 111, numbers 1, 2, 6, 9, and 10. You were supposed to do 1 and 2 in class, so you really only have 3 questions. Question 9 and technically question 10 are just like the examples we did. Try question 9 right now. That way, if you have any problems, we can talk about it before you go home.